class, this podcast has to do with percent yield. And percent yield is pretty much the last thing we're going to use that utilizes the concept of stoichiometry. And percent yield basically tells us what we can expect. So stoichiometry always helps us to predict how much product we can make. But whenever we do an experiment in class or in the lab, we get a certain amount. And that is, I would say, 99.99% of the time, less than 100% of what we'd expect. There's always some reactions that happen that we don't predict, whether it's stuff that was in the glassware wasn't completely clean, just by error from you. Sometimes the pressure isn't right, the temperature isn't right, and we never get 100% of what we expect. So manufacturers and producers have to know this reaction usually gives a 60% yield, which means if you want to make 100 grams of it, and you're only going to get 60% of what you want to make, you need to plan to make 180 grams of it, okay? So, again, percent yield is an equation, and this is the equation. Percent yield equals actual yield. So this is what you get in lab. So actual, this is lab, divided by theoretical. And theoretical is what you calculate on paper. Now this is what you do using stoichiometry. So this is calculated as opposed to lab. And you divide these two values, and then you're going to get some decimal number, and multiply it by 100 to get percentage. Okay? So we're going to go with an example. Given the following chemical reaction, 4 moles of ammonia plus oxygen yields 2 moles of dinitrogen tetrahydride plus 2 moles of water. So the question states, if you had 17.11 grams of ammonia and excess oxygen. So notice, this is a big hint. It tells us that our oxygen is excess. So if it is excess, then ammonia is limiting. So limiting tells us how much we can make. So if we have 17.11 grams of ammonia, and you are able to experimentally isolate 13.49 grams of N2H4, what was the percent yield for this reaction? So the other hint, or the other thing you have to notice, is experimentally. Okay? So experimentally is what happens in lab. So the number that I give you, alright, in this case it's the 13.49 grams. So the number I give you right here is the experimental number, or what we would say is the lab value. So we need to calculate the theoretical value. And notice I just said calculate. So we're simply going to do a stoichiometry problem, and we are starting with 17.11 grams of NH3. And we need to change this into grams of N2H4, because we know how much we got from lab. We need to find out how much we could theoretically make. So again, fence and rail problem, we're doing a mass-to-mass problem, which is what we've been doing a lot of. So this is grams. So we're going to let our units be our guide. So grams of NH3 goes to moles of NH3. And if we have moles and mass in the same fence post, that's known as molar mass. One number goes in front of moles, 1. And one number goes in front of grams, whatever it is from the periodic table. So if we add this up, we get 17.031 grams. And then our next fence post is going to be our mole ratio. So we're going to go from moles of NH3, or ammonia, to moles of N2H4, or dinitrogen tetrahydride. And this ratio is a 4:2 ratio. And then lastly, we don't want moles of the product, but we want grams of the product. So we're going to go from moles of N2H4 to grams of N2H4. Alright, and again, we have moles and mass in the same fence post, so it's molar mass. So 1 mole of N2H4 weighs how much? And it weighs 32.045 grams. So what we're going to do is we're going to multiply across the top, multiply across the bottom, simplify, and when we do that, we get 16.097 grams of N2H4. So again, this is what we theoretically could make. Alright, and we want to compare that to what we experimentally got in our lab, which was the 13.49 grams. So now we're going to use the equation that's written right up here. Percent yield equals actual divided by theoretical, and then we're going to multiply that by 100 to get a percentage. So our actual is what I will always give you, because it's a word problem, so you can't really do this in lab. Although you will do a lab where you're going to calculate this. So that's actual, and then theoretical is what we calculate, which happen to be 16.097 grams. Notice grams divided by grams, our units go away, and we're going to get some decimal number, but we're going to multiply it by 100% to make it a percentage. We find out that this percent yield, if we actually got 13.49 grams, is 83.80%. Alright? And again, percent yields will always be less than 100, because there's always things that happen that are out of our control, so we can't make as much product as we plan to make. But generally, if you're a manufacturer and you're doing the same thing over and over, you get, after doing this several hundreds times, tens of times, you'll know that we usually get about 65%, 63%, 62%, or maybe it's as good as 80%, or maybe it's as bad as 20%. But that's the way to calculate percent yield. We utilize stoichiometry for that, and then also look at values we get from our lab.